Today we're doing chapter 7, number 28, and the problem says a Bohr's model representing the hydrogen atom is shown on the board with several electron transitions depicted by arrows. And part A asks which transitions are absorptions and which are emissions. In this case, a general rule of thumb is that absorptions always goes from inside out. So this arrow right here will be absorption. And emission goes the other way. So emissions are right here. And the reason for that is you have right here in the center a nucleus, which is positive, and you have all these little electrons on the outer energy orbitals. And the electrons usually stay in orbital. In order for it to stay in orbital, the ones that's furthest away needs more energy to hold on to the nucleus. It's sort of like, imagine this as the Earth. The center is, this is the center of the Earth, and this is electron going up to the air. And the further away it goes up, the more energy it needs to absorb to get up there. So that's absorption. And emission, in this case, when you want to go from a higher energy level back down to a lower energy level, because of conservation of energy, some of the energy has to be released as some sort of heat or light or anything. So this will emit a light or something. So which is why from outside in is emission. So part A asks which one is absorption, which one is emission. And so absorption inside out, it will be A, C, and D. A, C, and D. And emission will be the other three, which will be B, E, and F. All right, part B asks, rank the emission in terms of increasing energy. So when you rank in increasing energy, it usually is the more levels it had to jump through, the more energy it takes to jump through those levels. So emissions, we already said, was B, E, and F. So when you count the energy levels that each one of these jump through, you can see that E will be the lowest because it only jumped through 1 and 2 energy levels. F will be the second lowest. It jumped through 1, 2, 3. And B will be the highest energy because it jumps all the way from level 6 down to 1, which skipped through 5 levels. So in this case, you rank it from least to most, which is E, F, and B. Whoops. B. Okay. Part C asks, ranks the absorption in terms of increasing wavelength of light emitted. For this question, we had to think about that the equation E equal to hv over lambda, which is wavelength. And with this relationship, you can see that the higher the energy, the shorter the wavelength. They have a reciprocal relationship. So also for this, for absorption, same thing as emission. The more level you jump through, the more energy it will take, which means shorter the wavelength. And with absorption, we establish it's A, C, and D. So A, C, and D, you can see that D is the one who jumped through the most energy level. It jumped through 4, and A and C both jumped through 3. So in this case, A have the most energy, which means they have the least wavelength. So we can see that the shortest wavelength will be D. And now we have to just distinguish between the C and A because they both have jumped through 3 levels. But now you have to see where they start. A starts at energy level 2 and C starts at energy level 3. And energy level 2 is closer to the nucleus, which means they have more attraction, which also means that it will take way more energy to pull something from level 2 apart than from level 3. So A will require more energy, shorter wavelength, and it will be the second shortest. And C in this case will need least energy, so I have a longest wavelength. And that's it.